Today I want to show you the solution of an integral problem from the CIE further mathematics past papers. This is an integral problem from 2008 or maybe 2018. I'm not so sure. Okay, let's start with the integral. It is still a trigonometric integral. The integrand goes like this. By the clue given by the problem, we know that we want to use the substitution. U equals tangent x, and then so we have to calculate the differential part. If u equals to tangent x, then du is equal to the square of secant x dx. And so we have this indefinite integral now transforms into like something like this. Now we see that something cancelling out, and so the integral gets simplified by some simple power rule we have, and so now we use the substitution conversely, so we get, okay, we are done. It's a very simple indefinite integral. So, and the second part of the problem goes like, now we are going to show a reduction formula for this definite integral. And first we may notice easily that this definite integral may be split into two parts with this with help of this identity. So here we are inspired to introduce notation for these integrals. Let us denote it by Jn, and so Jn is equal to this integral. Then we have In is Jm plus 2 minus Jn. Okay. And then we will calculate In by another approach, namely by integration by parts. Say it is something like this, and then okay, I will let me remind you this differential formula. Okay, and then we have by integration by parts, we have please remember that the differential of tangent x is the square of secant x dx. And this, so we have multiply both sides by n, so we have n times in equals to what? Equals to something like this. Okay, so we got another formula, like you see? Okay. We add these two identity, we get another one, that is m plus 1 multiplied by in equals 2. So these two terms are cancelled out like this. But still, it is not a reduction formula, but we are much nearer to the final answer, because now we notice the integral Jn, and by another trick of integration by parts. I hope you still remember this differential. We have like this. So by integration by parts, and this term is, say, some power of 2, and this term is something like, well, we have to treat this differential very carefully. So n minus 2 and something like this. Okay, so finally we got Jn equals to let's see. I want to shift this factor out. So we have remember the square of tangent x is just nothing more than the square of secant x minus 1. So again we have Jn equals to 2 minus, here we have Jn minus what? Jn minus 2. But this part, Jn minus 2 is nothing more than this part is nothing more than I m minus 2 because we have this one, right? So now we know that Jn is okay. Now we are done. So at last we got the reduction formula. Just plug this term here, plugging it, and we get the reduction formula like this. See, this part is say it is something like something like this. So the difference of these two powers is just another one. Okay, we are done. And as the final part, we are required to calculate I4. So by the reduction formula, we have let's here n is 4. So here we have 1 and okay, but still we know, we already know what I2 is, right? When n equals to 2, we have this reduction formula. So I2 is 1/3 and I4 is it is 8/15. So that's all.